It's another day and another stream. Welcome back to this little series where we're doing some AI development, or should I say we're doing some learning with AI to try to one day create an AI of our own. It's going pretty well so far. Yesterday, we almost finished going through this script here. Almost. We only have the CLI, command line interface, to go through, and that's that before it's time to test it. And I'm really excited about that. And tomorrow we'll have some more gaming to do. I'll be playing Windcraft, and maybe on Friday as well. I'm unsure about Saturday and Sunday, so we'll see about those days, but maybe we'll be back to more coding streams then. I can't really plan that far ahead. So with that out of the way, let's start. So instead of calling it the main, we call this function the CLI in the script. And we do the usual stuff. We create an org parser and create a sub parser of that org parser. And then we create the ptrain for the other training arguments. A parser, in other words, of that sub parser. So we have a parser of a sub parser of the argument parser, and we add all these arguments to the parser. And it's a bit annoying that it keeps like showing up like this tooltip so quickly. I wish I had to like click on stuff to bring it up. I don't know where to put my mouse otherwise. But other than that, we also have the encode here, but we only have one argument. No, never mind. We have more arguments down here. But in the meantime, we add a mutually exclusive group to the src. I don't know why, but src makes me think of source. But that can't be the meaning of src. It doesn't matter, I suppose. But we add the mutually exclusive group required to true, so we need to either supply a text or a file. And then we have these arguments as well for the lower or the normalization. And then we have for the decoding, likewise we add a parser and add the arguments for the model, and then for the IDs, and we've set that to required as we need something to decode. And then we also have the export parser argument here, or parser and arguments for the model, and the input, same training text for frequency counts, and the out prefix that defaults to gbt_export. And we set the variable args to p.parseArgs. So we have this whole object here that we're adding all this stuff to. And then we check if args.cmd equals train or command. Then with open args.input read with encoding a UTF-8 as f, then we read it and set that value to the raw variable here. And then we set the text variable to the return of the normalize function, which will do nothing but lowering, potentially, depending on the use of that argument. But we don't do any normalization, even if we pass that along, since that's been commented out in this function. And then we have the model, we set that to train byte PPE. And we supply the text that's been quote-unquote normalized. And we pass along the vocab size explicitly here. And then after we've trained the model, then we save it with the output path here that we've established in the args, possibly, depending on the export here. And then we print a message to say that we saved it. Otherwise, if the command is in code, and let's see, I suppose each parser in itself is a command of the argument parser. Or maybe of the sub parser. Yes, because we have destination CMD. So it's a reference to the sub parser. Or sub parsers. This is the first time I'm realizing it's a plural. Moving on. So if we have the encode command, then we load the model, since we've already used this at some point, most likely, to train a model. And as long as we supply a text, if it's a file or if it's like raw text, it doesn't matter. As long as we supply something, then we set the raw to that text. Otherwise okay, no, never mind. It's here that we check. So if we supply a text, then we set the raw to the text. Otherwise, we open the file and read that. And set the raw to that value or that data. And then we also set the IDs to encode text wrong. I'm going to ask if in VS Code, is there a way to remove the highlight tooltip that shows up whenever I hover over a variable, over a Python variable function class, etc. I'd prefer to have to click on it to bring it up instead of it showing up on merely hovering. It would make everything so much easier. Since I want to like visually go through everything with my cursor, and it's getting a bit much that it's always like bringing stuff up. Yep, two solid options. Option A, turn hovers off, show them only on demand. Open settings, then use the show hover command when you actually want it. Option B, keep hovers but makes them slower. I don't know which is better. I mean, either having a like longer delay would help some, because it's mostly that it's mostly like the timing that's annoying me. I don't know. It's quite useful as well. Yeah, I'm gonna change the timing to something better. In the settings, where did I keep that? Here. Let's set that to something very noticeable, like 5 seconds, and try again. So now it should be 5 seconds. Let's go on this one here. And that worked. Five seconds is a little bit extreme, but let's go with 3 for now. And because now I can actually move my cursor around without triggering that tooltip all the time. Tooltip, is that the correct word? Oops. Is it? It's empty. Here we go. I suppose I don't need to scroll in here. So moving on. I was looking at this line here. So IDs, we set that to encode text, and we supply the raw text and the model and the arguments for normalization and for the lowering. And we print all the IDs separated by commas afterwards. Otherwise, if the command is decode, then we load the model and we set the IDs to so we basically split on the comma, which should create a list of strings, since we're supplying them either through the terminal or through a file. And we also convert each string item into an integer. But I'm not entirely sure about this part here. If I'm gonna double check with Rufus. Break this down for me. Need to move my keyboard a bit again. So what each piece does: args.ids, a single string like from IDs, split turns it into, yes, for string, a list of strings, for s in, iterate each chunk, if strip, filter out empties, white space only chunks. But how does it filter them out? Handles things like leading, trailing commas or extra spaces. 1, 2, etc. 3, 2, oh, empty 3 will be this list here after if strip. I'm just stuck on the logic behind it. Like what? Where does this run? On what step does this run? On all of them? Perhaps? But then I would surmise that these wouldn't like become like this. Shouldn't it be like one here without white spaces on either side? Because as far as I'm understanding it, then the strip function removes white spaces at the beginning and end. So it makes sense that this white space here will be removed regardless, leaving like nothing. But this should also be removed if this is run. Okay. Equivalent unrolled code. For s in args.ids.split. So we loop through all the strings. Then we run fstrip. And then we append it as an integer. This looks wrong to me. On a fundamental level. I don't know why. Like, this isn't a... S will never look like this. S will be like one character. Is this wrong? I'm gonna see what it says. Maybe a bit vague, but... Okay. Yes. Makes sense. That makes less sense. Like, where is the space coming? You don't filter empty instead of trailing commas. But where is the space coming after the split? Does the split function automatically add a white space behind each comma for a reason? I'm not understanding. But shouldn't... Whoops. Cancel that. But shouldn't strip remove any white spaces afterwards? So s.strip in the if only checks is this piece non-empty after trimming. Oh, so it doesn't actually trim anything, it only checks. That makes so much sense. So as long as s.strip returns something more than nothing, then we add it to the IDs. That way we bypass any white spaces. And that's also why any potential spaces would still get like through this step here, since we don't actually modify the s. And then we have the int conversion here that converts the string to an integer. And by doing that, we finally clean up the any potential white spaces. I finally understand it. Took a while, but feels great. Then we have the text equals decode IDs. So we pass along the IDs that we simply converted from the strings to integers, and the model that we loaded. And then we print the return of that decoding. And then we also have the command for export. So we load the model and we read the file. We read the input file. No. What is this doing? Is this input from like the command line? This doesn't tell me anything. It would make sense if we input something in the command line and then we read that file and store it as a raw. And then we export the model, the raw data with the argsout prefix. And then we print the name of the exported JSON, vocab JSON, and wait, is this correct? For some reason I'm imagining it to be like this. Yeah. Just a typo from before. And then we have the check here to make sure this isn't imported as a module and that we're actually running this directly. And then we do run it. Okay. So we need data.txt. We have the toy.txt. Just rename this to data, I suppose. It's not a lot of data though. Let's rename this back to toy and rename this to data. It's a lot longer. And I think we're done. I've gone through everything. And I think everything is clear. Let's just try it out. So we have the terminal and it's the PowerShell. By bpe dot I train, the train command, and the text file in question. So data.txt, and we set the vocab size to 320, and we do lower. We do normalize, even though that won't change anything. And we set the output to byte bpe dot model .json. Let's try it out. And we had no crashes. 0 crashes. Excellent. And we should be able to see a model somewhere here, byte BP model. And we have a single token string. This is the whole text, in other words. Wait, no, this is the whole vocabulary, in other words. And here we can see after this this is the end of the default vocabulary. And then we move on to the more specialized errors and stuff like that. And we even have 3 of them here. And 4, my guess is that 320 in vocabulary size is a bit too small. And it seems we appended a space ID at the end here. I don't remember seeing that in the code, but it makes sense. Oh, because we have this is a dictionary. Yes, that makes sense. So this is the key and the values, and we're missing the 256 that should be present here otherwise as a hex value. And instead we're having it here. And we have then 256 like this when it's a actual space. Okay. So then we also have let's see the next one here. Encode some text. So we should probably encode text that actually we've trained on. I'm gonna do this again, but I'm gonna increase the vocabulary size to something a bit more like, let's say 1000. I don't know if this is too much, but it should be fine. Took a while longer, that's for sure. And this should now be a lot longer. But we also have some longer words as well. Show more. Okay, so this file is actually quite large. Oh. Reveal properties 25 kilobytes. For being nothing but numbers, that's actually pretty impressive. How much was this model here? It says 1 kilobyte, but it might be even, yeah, it's even lower. But now we have a much larger vocabulary and should be able to... Wait. So, next one, Python. Next one is to encode some text. So Python byte bpe.py encode byte bpe.model.json. So we grab the model that we just trained, and we see that the text is the rock gazed at the sky, dreaming of something more. And then we say lower and normalize. And I spelled that correctly. Seems like it. And enter. So this becomes the encoded version of this text here. Copy that. And then we can decode it. So Python byte bpe.py decode byte bpe dot model dot json, and we supply the IDs like that, and we don't do anything else. And we get back the rock gazed at the sky, dreaming of something more. And we lose the capitalization, of course, since we're doing the lowering when we encoded it. But otherwise, everything seems to be in order. And then we have the export. So Python byte bpe.py export byte bpe.model.json data.txt out prefix gpt2. Okay, so we'll take both the data and the model and export it somehow. Here we have the merges, and here we have the JSON. So let's check the JSON first. Oh, and this is space. I have no idea why we use this weird character instead of space, but Grok, is that you? Gwei. Cloned. Camille. Go. There's a lot of strange words here. At least to the human eye. And these... These are the rankings. How often they appear. So space and the. I don't know why space is such a strange... Space should be like the first. We're having some strange character here that we can't even... Let's check the merges. So... Oh, these are two different. So space and T is very... Wait, is this ordered in... It should be in order of most common. Because space and T for the or that or whatever should be pretty common. H and E. Space and A, space T and HE. Oh, that's where HE comes in. And space S, space W. I think we get the point. Pretty interesting to look at though. And that was that, I think. We could do some testing as well, but I don't really see the point. I mean, I would do the testing if, let's say, we had an error or something like that. Then I would feel like obliged to do the testing. But I'm either missing something or this seems very extra. Why this design? Byte coverage. Space token, replay merges. So I suppose that's that. Exercise 9. The byte level BPE. Did we get any hints on the next? No, let's just ask it to move on, I think. Oh, And grab this chest here. Duplicate. Now I'm going to try to do extended thinking. Let's move on to the next exercise. Might take a while though. Moving on to exercise 10, so at least it found the correct exercise at least. PyTorch. I've heard about PyTorch before in context of LLMs, but I have no idea what it's about. I'm honestly just thinking about Minecraft torches when I read torch. But I suppose you could also call a torch like a flashlight, a torch, but is that British English or maybe even Australian? I don't think Americans call flashlights torches, do they? Hmm. 1 minute isn't so bad for a thinking time. We had like 5 minutes at some point. Was that when planning exercise 9 it thought for like 5 minutes. If I remember correctly. Okay, so let's start by reading this here. Great, exercise 10 time. NumPy/PyTorch warm up. You'll learn stable softmax/logmax stable softmax/log softmax, cross entropy, autograd, and a tiny training loop. Minimal files plus tests below. Drop them. No, I'm not going to drop them. I'm going to actually write them. So we're getting straight into some more complex topics. It says basics. All right. I'm just gonna ask. What is this NumPy and PyTorch in Python?
In a nutshell, NumPy and PyTorch are both libraries that help you do numerical computing in Python, but they have slightly different roles. NumPy is basically the go-to library for doing all sorts of math on arrays and matrices. It's kind of like the bread and butter for numerical operations. PyTorch, on the other hand, is more specialized for machine learning and deep learning tasks. It uses a lot of the same ideas as NumPy, but adds features like automatic differentiation and GPU acceleration, which are really handy for training neural networks.
All right, these sound pretty essential to what we're doing. But I'm not gonna lie, my math is, well, not the greatest. It's been years since I last studied math seriously, so we'll see how far we get in this project, I suppose. No, we'll probably go all the way, but it might take some time to read up on like this math here to understand it. Or maybe not. I'll never know before actually starting. So we have the basics here, and we have torch warm up. And this seems to be something training. I don't know what it's training, but something. And a test file for the tests. And a test file for the warm-up. Here we might actually need to do the test files to make sure the math comes out correctly. And then we have, we simply run the tests. Might want to install it as well. Why these pieces? Stable softmax / log softmax. Subtracting the max log sum exp trick. Prevents overflow / underflow. This matters for training stability. Cross entropy. We compute minus log softmax at the target index. Then mean over the batch exactly what f.cross entropy does. Autograd sanity. Finite differences check that PyTorch's gradient matches a numeric approximation on a tiny linear model. Training loop. Shows the minimal pattern, forward, loss, zero grad, backward, step, and... Oh, I'm dropping frames. I'm just gonna wait for it to get back to normal. And we should be back. I don't know why this is happening. I dropped like 10k frames suddenly. Sometimes. It should be my internet provider, but it might also be a problem on my end. I hope not. I almost hope it's the ISP. Because I've done a lot of research on how to set this up, so there should be no problem. And if there is a problem on my end, then I'm honestly way out of ideas on how to fix it. There's simply no way. But it's working again. And it's only the upload speed that gets throttled to like 2000 kilobits per second for like a few minutes sometimes, but not every day. I think yesterday I had like 2 hours of streaming without anything happening. So I don't know. It might be simply be network instability. But getting back to this, I don't know where I was exactly when I dropped the frames, but I think I read through all of this. So autograd sanity, finite difference check with PyTorch gradient matches, a numerical approximation on a tiny linear model, training loop shows the minimal pattern, forward loss, zero grad, backward step, and validates that the model actually learns. When this is green, we'll use the tokenizer to build a tiny dataset and hook a min transformer onto this foundation next. So what I don't understand is, I don't understand what this even is, to be honest. I mean, I could follow along on the encoding here, but I don't see the purpose of this. Is it to make it more accurate, or to make it more efficient, to add some unknown functionality? I simply don't like know the basis as to why I need this. Explain to me why I need numpy / PyTorch. What is its purpose in relation to my goals? Why do I need it? Wait, I already asked that. That should be enough, I think. I'm gonna do extended thinking on this as well, to make sure I get a answer that actually takes in all the variables and considers it carefully. Short answer. You can write a tokenizer in plain Python, but you can't train a neural net efficiently in plain Python. NumPy and PyTorch gives you the fast, vectorized math and automatic differentiation you need to build and train your tiny LLM. How they fit your goal. NumPy, learn and prototype the math, what it is, fast n-dimensional arrays plus vectorized operations. Runs in C under the hood, and C is fast. Why you need it? To understand / verify core math. Softmax, log softmax, cross entropy, normalization, without autograd magic. Where it shows up. You will sanity check your math against PyTorch, write this is NumPy though. Okay, where you're sent to check your math against PyTorch, write tiny numeric demos, and build intuition for stability tricks. For example, subtract max before AXP. PyTorch, build and train the model. What it is? Tensors like NumPy plus autograd, automatic gradients, okay. So autograd stands for automatic gradients, plus GPU support, plus layers/optimizers. So that's PyTorch, all of this. Why you need it? Training equals compute loss to compute gradient to update millions of parameters. Autograd does the backdrop for you, CUDA/optimize kernels do it fast. Where it shows up in your mini transformer. I don't know what transformers are yet, but embeddings, lookup tables, big matrices, attention, batch matrix multiplies, MLP, layer norm, residual, standard layer, torch NN, loss/optimizer, training loop, forward loss, zero grad, backward step. Division of labor in your project. Tokenizer BP/byte BP. Plain Python is fine. What you've done, it output token IDs. Data pipeline. Turn token IDs into training sequences/batches. Can be Python or PyTorch. Dataset/data loader. Model plus training. PyTorch for everything for embeddings onward. NumPy remains useful for quick checks and small experiments. So PyTorch contains NumPy, but NumPy in itself I can use for quick checks. Okay. Why not just use pure Python loops? Speed. Python loops do scalar work. LLMs need massive vectorized ops or operations. Matrix multiplies. Matrix multiplies. Stability, libraries implement numerical stable versions, for example logsum, exp, fused cross entropy. Gradients. Hand coding backdrops for every layer is brittle and slow. Autograd is reliable and fast. CPU versus GPU. Your tiny model will train on CPU just fine for learning. If you add a GPU later, PyTorch can use it with minimal code changes. Okay. NVIDIA really did make everything easy to use on their hardware when it comes to AI and training and stuff like that. Okay, so mental pipeline. Oh, this is great. This is what I want to see. So we have the text, we have the tokenizer, which we've built here, which returns the IDs, and which will be turned into batches, is my guess then. PyTorch tensors as like NumPy. Then we have then that will be passed on to the model, which will make in PyTorch. And we'll pass that on to logits, whatever that is. Or we'll do logits or something. Let's say after the model it comes times for the logits. After that it is time of cross entropy loss, and then autograd computes gradients, and then optimizer updates the weights of the neural network, and then we decode samples with the tokenizer. So we return it back to text, probably. Why we're doing the NumPy/PyTorch warm-up now? It teaches the exact primitives you'll use in the transformer. Stable, log, softmax, cross entropy, tensor shapes, batching, and the training loop pattern. We will reuse this understanding when we implement the attention, embeddings, and the end-to-end training script. If this makes sense, we'll keep exercise 10 focused, implement stable softmax, log softmax, cross entropy in NumPy, mirror them in PyTorch, confirm they match, then run a tiny training loop to prove the pieces work. Okay. That sounds good. Complex, but good. I'll have a lot of studying up to do on this. Or a lot of questions for the AI, more like. But I'm honestly a bit excited to get to the next step. But that will have to wait for another day. It's been about an hour, so a really short stream today. But I'll be back tomorrow with some gaming streams, and maybe on Friday as well. Then I might do some coding later on Saturday, but probably not Saturday, but maybe on Sunday. Otherwise on Monday next week. And then we'll dig right into this meaty stuff here with all the math and stuff. Yeah. It was really fun to see the tokenizer in action. I hope you've enjoyed the stream so far. And I'll catch you in the next one. Smash those buttons and yeah, cheers!